With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So today's our question is, a sample of an ideal gas is taken through the cyclic process ABCA. Okay, we have given an ideal gas, sample of an ideal gas which is going through a cyclic process, that is A to B, B to C, and finally C to A. Okay, it absorbs 50 joules of heat during the part AB. Okay, so the ideal gas is absorbing a heat of 50 joules in the process A to B. Okay, and no heat during BC. So in the process B to C, no heat is absorbed or rejected, and rejects 70 joules of heat during C to A. Okay, so it is rejecting a heat of 70 joules. Correct? Now further on, 40 joules of work is done on the gas during part BC. Okay, so during the process B to C, work done on the gas is 40 joules. Okay, so 40 joules. Now, we have been asked that find the internal energy of the gas at B and C. So we have to calculate in the first part the internal energy at B and internal energy at C. In the second part, we have to calculate the work done by the gas during the part C to A. So we have to calculate the work done in the part C to A. Further on, we have been given that the value of internal energy at the point A as 1500 joules. Okay, so value of internal energy at point A is how much? 1500 joules. So now in the part AB, that is when the sample of ideal gas goes from A to B. Okay, so the process from A to B is what? Constant volume process. Correct? Or we can say it as isochoric process. Correct? In the isochoric process, as we know that work done is 0. Now from the first law of thermodynamics, okay, what we can say, that the change in the heat is equals to the change in the work done plus change in the internal energy. Correct? From here, on substituting the values for the process A to B, we get dq is equals to 50 joules and dw as 0 plus change in the internal energy will be internal energy at point B minus internal energy at point A. Correct? From here, we get the internal energy at B, that is 50 joules plus 1500 joules. Correct? From here, we get the internal energy at point B as 1550 joules. So we get the internal energy at point B. Similarly, for the process B to C, okay, for the process B to C, we have been given that heat in the process B to C is how much? 0. Okay, now again applying the first law of thermodynamics, we get dq in at C is equals to dw in the process B to C. Correct? Plus change in the internal energy, so UC minus UB. Correct? Now substituting the values, respective values, we will get the change internal energy at the point C. Okay, so 0, and the work done in the process BC is minus 40 joules plus internal energy at point C minus internal energy at point B, we have calculated 1550 joules. Correct? Now from here we get the internal energy at the point C as 1590 joules. Correct? So we have calculated the internal energy at point B and point C. Now in the second part, we have been asked the work done in the process C to A. Okay, so for the part B, for the process C to A, what we have been given? We have been given that the amount of heat rejected in the process C to A is minus 70 joules, and we have calculated the internal energy at point C, that is 1590 joules. Correct? Internal energy at point A was given in the question as 1500 joules. From here we can calculate the change in the internal energy in the process as UA minus UC. Correct. UA minus UC will be how much? 1500 minus 1590 joules. It will be coming minus 90 joules. Okay, so change in the internal energy in the process C2A is minus 90 joules. Again, applying the first law of thermodynamics, what we will get? The change in the heat in the process C2A is equals to the work done in the process C2A plus change in the internal energy in the process C2A. Okay, so substituting the values, minus 70, we have to calculate the work done in the process C2A plus change in the internal energy, how much? Minus 90 joules. Correct. From here we get the work done in the process C2A as 20 joules. Okay, so this is our answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.